Hello students, how are you all? Today we'll discuss about the nature of image formed by a convex lens. Yes, for that we will discuss 6 positions of object. We will place our object means say a candle we are taking, and we will keep our we'll keep our object in 6 different positions of the lens. Then we'll take out the nature of images formed by that convex lens. But I suggest you, before watching this video, you must see the first part of this video, and the link of that video is given in the description box. You must watch that video first and after come to this video. So let's start. First of all, you can see that from our first video we know that this is the convex lens, this is called pole, and this is optical center, center of curvature, focus point, center of curvature, focus point. We know that from our first video. Now we will send our rays, but ray will come from the object. Number A, we will place our object at infinity. We are keeping our object far away from the lens. Far away means where the object is will not be shown here. We are not drawing the object here. So my object is at infinity. It's far away from the object. From the lens. Now, since the object, we are not showing the objects, so we will take out 2 rays from that object. So this is the first ray which is coming from the object which is far away. This ray is coming, and here another rays are coming. 2 rays are coming, and we will send these 2 rays through the lens, and after crossing the lens we will see where they are intersecting, and where they are intersecting, that is the position of the image formed. Let's discuss this. Here are 2 rays. From the first video, we know that when the rays are parallel to the principal axis, here all these rays are parallel to the principal axis. So they will pass through focus point. Yes, this way. So where the image is forming? Here. So where image is formed? Image formed at focus. Understood? Number B. Object is beyond center of curvature. We will take our object and place it beyond center of curvature. Like this is the convex lens, pole. We know all this from our first video. Now we are placing our object here. Now from this object again 2 rays will go and pass through this lens, and after passing through the lens where they are meeting, that is the position of the image. Let's see. First ray is going parallel, and second ray is going through the optical center. So that will go straight, we know that, and that will pass through focus point. So this is my image. So I am getting my image between focus and center of curvature. So I can write that I am getting my image formed between C and F, between center of curvature and focus point. Number 2, see, the image is forming that side. if image is forming that side of the lens, this side of the lens, I mean right side of the lens, then we call it real image. Don't forget. So this is real image. I repeat, if you are getting your image on the right side of the lens, this side, then this is real image. If you are getting your image this side, then this is a virtual image. So here we are getting real image. Number 3. What is the size of this object? This much. What is the size of this object? Image is less than this. See, which is bigger? This object is bigger, but image is smaller than, size of the image is smaller than the size of the object. In that case, we'll write that this is called diminished image. Diminished image. Now, we kept our object straight, see, upright, but we are getting our image this. So we call it inverted image. Number 4, inverted image. Understood? This is called inverted image. If you get an image of this kind, this way, like this way, then we call it erect image. But here we are getting inverted image. So what are the natures we have got? Image formed between center of curvature and focus point. Real image. Why real image? Because the image is forming this side. If image forms this side, then this is virtual, but this side, this is real. Now, number 3, diminished, because the size of the image is less than the size of the object. Number 4, inverted image. Why? This way. If you are forming this way, if you are getting an image this way, straight, then erect. But we are getting this, so it's an inverted image. Now let us discuss next condition. Number C. Now we will keep our object at center of curvature. So object is at center of curvature. This is my lens, pole, so I am keeping my object here. This is the position of the object and this is the object. Again, from the object, 2 rays will go. This is the first ray which is going. That will pass through focus point. And another ray is going through the pole. This is the diagram. So where you are getting your image, we are getting our image on other center of curvature. So number 1 we can write image is at center of curvature. Number 2, this is the size of the object and this is the size of the image. Both are same. Yes, this is the only position of lens where if you are keeping your object, you get an image of same size that of the object. So object size and image size are same here. So size of the image is same as object. Number 3. This is a real image or virtual image? Real image. Why? Because image is forming that side. So this is real image. Number 4. It's an erect or inverted image. It's an inverted image. Why? Because we are getting this way, down to the principal axis. This is the object, but this is the image. So this is an inverted image. Inverted. Now, next position. Number D. Object is in between C and F. This is the lens O. Now I am keeping my object here between center of curvature and focus point. Center of curvature and focus point, I am keeping my object. Again, two rays will go. First ray is this, which is passing through focus point, and another ray is passing through pole. So here it is meeting. So this is my image. Yes, I'm getting this image now. So where is the image? The image is forming beyond center of curvature. So number one, image formed beyond center of curvature. Number two, see, this is the size of the object, but the size of the image is much higher. So it's an enlarged image. Yes, because the size of the image is bigger than the size of this object. So it's an enlarged image. Enlarged. Number three, it's an erect or inverted. It's an inverted image. This, not this. Inverted image. Inverted. Number four, it's a real or virtual? It's a real image because we are getting our image that side. So it's a real image. Understood? Next position. Number E. Object is at focus. Again, this is the lens. Now, this is the object. From here, the ray is passing and another ray is passing through pole. So, this ray will pass through focus point, we know that, and this ray will go straight. See, these rays are not meeting. But you can say that they will meet at infinity, means far away from the lens. They will meet far away from the lens and you will get an image which is at infinity. So, where is the position of the image? Infinity, means far away from the lens. Infinity. Number two, it's a real or virtual image. That side, so it's a real image. Number three, it's an erect or inverted. Obviously inverted image because they are meeting there at the far away and there you are getting the image which is inverted. Number four, what is the size of the image? Size of the image is much bigger than the size of the object. Yes, there you will get an image whose size is much higher than the size of this object. So we call it highly enlarged image. Highly enlarged means much bigger than this object. So highly enlarged. Okay. Next point. Number F. Now object is in between F and O. Means this is your lens. Pole. This is your principal axis. Focus point, center of curvature. Other focus point, other center of curvature. Now we are keeping our object here. So again two rays will go. First ray is going like this and other ray is going like this. We know that since this ray is parallel to the principal axis, it will pass through focus, and other ray is going through optical center straight. So they are not going to meet because both the rays are diverting. This way they are diverting. One is going this direction, another is going this direction. So they will never meet at infinity. What we have to do, we have to produce them at back like this way. So we will get this as image. Now we are getting this image. What is the nature of this image? Number one, we are getting the image between center of curvature and focus. So between center of curvature and focus. Number two, this is real or virtual? This is a virtual image because image is forming left side of the mirror. If image is forming right side of the mirror, we call it real image, but this image is forming this side, so we'll call it virtual image. Yes, virtual image. And one more thing I want to tell you, it's an important question for your exam, that where will you keep your object to obtain a virtual image? The position is this. So we have to keep our object between focus and optical center to obtain a virtual image. Number three, what is the nature? See, this is the size of the object and this much is the size of the image, which is much higher than this size. So it's an highly enlarged. Number four, it's an erect image or inverted image. I told you this is called inverted image, but this is called erect image. See, erect image. So with number F, we have finished all 6 cases. So first case, we kept our object at infinity. Number B, we kept our object beyond C. Number C, we kept our object at C. Number D, we kept our object between C and F. Number E, we kept our object at F. Number F, we kept our object between F and O. This case, F and O. So all these ray diagrams, and while drawing these ray diagrams, these arrows are must. If you are not showing the arrows, means you are not showing the direction of the rays, and which is a big mistake for this type of ray diagrams. So don't forget to give these arrows, and you practice it. Diagrams are very easy, but the condition is practicing. You need to practice, and easily you can make those diagrams. Thank you.